Welcome back to the Learning Studio. You're watching our mathematics series, where we uncover the foundations that shape science, technology, and artificial intelligence. If you're new here, don't forget to follow us by clicking the link below. And remember, the full playlist is also in the description so you can explore every episode in order. Today, we turn to one of the most practical and powerful areas of mathematics: optimization theory. It's the science of finding the best possible solution in a world full of choices and constraints. Here's a simple example. Imagine you're packing a suitcase for a trip. You want to maximize what you take, but you're limited by space and weight. Which items should you choose? That's an optimization problem. Now, scale that idea up. Businesses optimize profits, engineers optimize designs, and AI models optimize millions of parameters. From the smallest everyday decision to the largest technological systems, optimization is quietly at work. Core concepts explained simply. Here are the essentials of optimization theory. Convex optimization. Imagine a bowl-shaped curve. Drop a ball inside, and it will always roll to the lowest point. That's convex optimization. Problems shaped in such a way that finding the global minimum is straightforward. These problems are widely used in machine learning and operations research. Unconstrained optimization. Sometimes we just want to minimize or maximize a function without restrictions. For example, finding the lowest point of a curve using derivatives. Constrained optimization. In the real world, we almost always face constraints, limited resources, time, or materials. Constrained optimization asks, what is the best solution that also satisfies all the rules? Techniques like Lagrange multipliers help solve these problems. Applications. From linear programming to nonlinear methods, optimization gives us the tools to make smarter, faster, and more efficient decisions. Why it matters in AI and technology. In artificial intelligence, optimization is absolutely central. Training a neural network is nothing more than an optimization task. We're minimizing error, adjusting millions of weights, and searching for the best solution in an enormous space. Optimization also powers logistics, route planning for delivery services, portfolio management in finance, and energy-efficient designs in engineering. Even your GPS navigation app is solving an optimization problem every time it finds the shortest route. So, optimization theory is not just about mathematics, it's about decision-making. It's the hidden strategy that ensures we don't just find a solution, but the best solution. In our next episode, we'll move into information theory, the mathematics of communication. We'll explore concepts like entropy, mutual information, and coding theory, which explain how data is stored, compressed, and transmitted, the very principles that make the internet, AI, and modern communication possible. Don't forget to follow us by clicking the link below and check out the full playlist in the description. Each episode builds on the last, and trust me, you don't want to miss what comes next.